जी औज़ुबिल्लाहिमिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम अस्सलाम वालेकुम। कैसे हैं आप लोग? मैं ठीक। मेरा नाम कासिम है और आज हम जो हमारा पास्ट पेपर मैराथन और टॉपिकल वर्कआउट चल रहा है उसके अंदर जो आज हमारा जो टॉपिकल वर्कआउट का सेशन है, जो यूट्यूब कम्युनिटी के ऊपर जो मैंने पोलिंग लगाई थी जिसके अंदर वोट्स करने थे और देखना था जी कौन सा टॉपिक की आज प्रैक्टिस करनी है, उसके मुताबिक जो है ट्रिग्नोमेट्री के सबसे ज़्यादा वोट्स आए। सो टुडे वी शैल बी प्रैक्टिसिंग trigonometry. So before we start off with the trigonometry, I would like to talk about few formulas here जिनको हमने रेगुलर बेसिस पे यूज़ करना है। ट्रिग्नोमेट्री बेटा याद रखें एक मेंसुरेशन के आगे सब चैप्टर आ जाता है या सब सेक्शन आ जाता है। बेसिकली इट्स अ पार्ट ऑफ अ मेंसुरेशन वेयर यू विल बी डूइंग सम मेजरमेंट्स। अच्छा, यहाँ पे ट्रिग्नोमेट्री के अंदर यू विल बी प्योरली डीलिंग विद ट्रायंगल्स। ओके, तो आगे बढ़ने से पहले सबसे पहले तो कुछ बेसिक्स पे आ जाते हैं। आपके पास जो इसमें जो दो इंपॉर्टेंट चीज़ें हैं, सबसे पहले जो एक बिल्कुल बेसिक से स्क्रैच से स्टार्ट करते हैं। सो इन एनी ट्रायंगल द सम ऑफ ऑल थ्री एंगल्स इज ऑलवेज इक्वल्स टू एंगल ए प्लस बी प्लस सी दैट इज इक्वल्स टू 180 डिग्रीज। ठीक हो गया। दूसरी इसके अंदर इंपॉर्टेंट बात आती है, अगर आपके पास ये एक इक्विलैटरल ट्रायंगल है, जस्ट बिकॉज कि इसकी ऑल थ्री साइड्स की लेंथ बिल्कुल एक जैसी है, उसकी वजह से जो इसके बिल्कुल ऑपोजिट एंगल्स होंगे ये सारे भी एक जैसे होंगे। So if you divide 180 into three equal parts, you are going to get 60 degrees each. So in an equilateral triangle, each angle is of 60 degrees. Now if I apply the same property on an isosceles triangle, तो फिर यही बात कुछ इस तरीके से हो जाती है। उसमें आइसोसेलेस ट्रायंगल में आपके पास कोई से भी दो साइड्स जो हैं उनकी लेंथ आपके पास इक्वल होती है। जस्ट बिकॉज द टू साइड्स आर इक्वल, angles opposite to those two sides, they are going to be exactly same. So for example, if this one is of 40 degrees, then this one is going to be of 40 degrees as well. Now if I apply the very same concept on a scalene triangle in which none of the side is same as the other one, so where basically all three sides are of different length, तो वहाँ पे अब साइड्स, अब ना जब मैंने आपको इक्विलैटरल ट्रायंगल की बात की एंड देन आई टोल्ड यू अबाउट एन आइसोसेलेस ट्रायंगल, you should be able to see a pattern emerging where you are able to notice a relation between the length of the sides and the angles opposite to them. So in an equilateral triangle, all three sides were equal, so all the angles opposite to those three equal sides, they were same size. And in an isosceles triangle, the only two sides in a triangle were of same length, so the angles opposite to those two sides, they were of exactly same size. In a scalene triangle, none of the side is same as the other one, so no angle would be same as the other one. So that's the relation. Now what is the importance of this relation? Sometimes you may get a question in exam where there is no diagram drawn and the examiner may ask you, he will only provide you with the three lengths and he will ask you find out the largest angle. Then how would you know that which of the three angles in a triangle is going to be the largest? I will show you that question today, inshallah. Now in this scalene triangle, basically this is the concept which we shall be using, the relation between the sides and the angles here. The largest angle will be opposite to the largest side here, and the smallest angle would be equal to the smallest side here. ठीक हो गया. So this is the relation which was important here, so that is why I mentioned here. So relation, the second point was about the relation of angles and opposite sides. Okay, now when you now specifically talking about now the pure trigonometry section where we will be talking about the different methodologies, formulas and techniques when it comes to solving of a triangle. Remember, in any triangle there are three sides and three angles, so basically there are six different components. So side 1, side 2, side 3, angle 1, angle 2 and angle 3. So these are the six things which you will be needing to figure out. So before we jump to that, we will be dividing the triangles into two categories when it comes to the solving of triangles. So on one side, I'm going to put right angle triangles, and on the other hand side, I'm going to put non-right angle triangles. So these are the two categories here. So when you have a right angle triangle, so basically whenever you come across with a question in exam, the very first thing which you are going to do is look for it, that what type of a triangle you are dealing with. If it's a right angle triangle, then you will be using techniques, formulas mentioned here. And if it's a non-right angle triangle, means it could be acute, it could be obtuse angle, so whatever it is, but it should not be a it should not be a right angle, then we will be using specific techniques mentioned under here. Now for a right angle triangle, we have two set of techniques. We have a Pythagoras theorem, and then we have trigonometric ratios. Now this is very important. You should know that which method is to be used for which particular type of a triangle. I have seen students applying sine rule and cosine rule on a right angle triangle, which eventually gives you the answer, but the crux and the core purpose of or you can say the learning objective, it doesn't or the assessment objective, that is not met. So you need to make sure you are attempting your question as per the assessment objective of the question. Now moving on the right side of the group, we have non-right angle triangles. Non-right angle triangles, we have two options here. Either we will be using sine rule or we shall be using cosine rule. Okay, now this is the main categorization here. So let's just start from the first one here, and I'm going to work my way all the way down to the cosine rule. Now the first thing is Pythagoras theorem. Now Pythagoras theorem states, so I'm not going to give you the pet formulas directly. I will not recommend, I always recommend my students to understand the concept and the relation of the formula with the actual shape. So for that purpose, I'm not giving you the formula directly. Instead, I'm going to give you a general statement which basically describes the Pythagoras theorem. From that statement, you can always derive the formula. Now, according to the statement of the Pythagoras theorem, hypotenuse is always equal to the sum of squares of other two sides. Now you may have noticed I'm not using the term here perpendicular, and I'm not using the term here base, because I do not recommend these two terminologies at all. It is fine if you're okay with that, but in Cambridge examination, we're dealing with different shapes other than triangles as well. So I've seen that the student, they after studying these types of terminologies as base or the perpendicular, they have this kind of misconception in their head that whenever a horizontal line is, or whatever the side the triangle is standing on, that is going to be the base of the triangle. So that is why I don't suggest those names, which is a wrong idea. So hypotenuse is always a hypotenuse squared, actually hypotenuse squared is always equal to the sum of the square of the other two sides. Now let me just relate this with any right angle triangle. So I'm going to draw a right angle triangle here. So here we have a right angle triangle. So I'm going to just name them randomly. So I'm not going to use standard names here. So let's just say I call this as P, I call this as Q, and I call this as R. Now whenever you come across with a right angle triangle, the very first thing which you're going to do is tag the hypotenuse, because that's the only side which has a standard name. As I stated earlier, base and perpendicular, I will not be using those names because they are not standard names. Whereas the hypotenuse, that's a standard name and a universal name. Hypotenuse stays hypotenuse no matter what. Now there are two indicators for the hypotenuse, even so you should know both of them, because depending on what type of question you get, one of the indicator is that hypotenuse is the longest of all three sides. So longest of all three sides. And the second indicator for the hypotenuse is it's always opposite to a 90-degree angle. So in this particular triangle, if you can clearly see that the side B is the longest, and you can check the location for the side B, it is also opposite to the 90-degree angle. So as I stated earlier, the very first thing which I'm going to do is whenever you come across a right angle triangle, tag the hypotenuse. It makes your life easy. Now let's just derive the formula as per the statement of a Pythagoras theorem. So it says hypotenuse squared, so P squared, that would always be equal to the sum of the square of the other two sides. So P squared would be equals to q squared plus r squared. So this is the formula as per the statement. So I did not tell you the formula c squared equals to a squared plus b squared. I did not tell you the formula a squared equals to b squared plus c squared. I've seen students memorizing these formulas, c squared equals to a squared plus b squared, but the drawback or the downfall for that, memorizing the formula directly without knowing the relation with the shape, the problem is that they don't realize that what is actually c and what is actually a and b. So that is why I recommend you memorizing this statement here. And then, or even if you want to memorize those formula, then make sure you know the relation, that what is c actually in the diagram. Even if there is no diagram, you should have in your subconscious mind that c is going to be the hypotenuse of the triangle. So this is the Pythagoras theorem. Now if you look carefully at the structure of a Pythagoras theorem, this one here, the p is the hypotenuse, which is one of the sides, q is also one of the sides, and r is also one of the sides. Now if you look carefully at the structure of this equation, there is no involvement of angle. So basically this is the limitation of a Pythagoras theorem, that you cannot work out your angles of a triangle by using a Pythagoras theorem. So that's one limitation. Another limitation is that you will not limitation, I would rather say checkpoint, that if you want to use a Pythagoras theorem, then you need to make sure that there are two sides provided in the triangle. Because if you look at the structure of this equation, there are three variables here. So that's a rule of basic algebra. If you want to solve an equation, if this is an equation, if you want to solve an equation, there should be one unknown. So if I want to work out the value of p, I need to make sure I have the value of q and r. And exactly in the same way, if I want to work out the value of q, I need to make sure I have the value of p and r. And same goes for the r. I need to make sure I have the values of p and q respectively. So after that, once you plug in the values, make the required variable the subject of the equation, and you will have your answer. So this was a Pythagoras theorem. Now next thing is trigonometric ratios. Now trigonometric ratios, there are three trigonometric ratios. The first one is sine of the angle x, second one is cos of the angle x, and the third one is tan of the angle x. So these are the three trigonometric ratios which are the part of IGCSE and O-level syllabus. Now these three trigonometric ratios work in a way that sine of the angle x is always equals to the opposite side to the angle x over the hypotenuse. Now yes, many students may have memorized the same formula as perpendicular over the hypotenuse, but as I stated earlier, I personally don't use, and I also don't suggest my students to use these types of terminologies, perpendicular and base, because there is a downfall for these types of terminologies. And unless you know what you're doing, then don't use this formula. That is why stick to the terminology which makes sense. Okay, now exactly in the same way, cos of the angle x is always equals to the adjacent side to the angle x over the hypotenuse, and tan of the angle x is always equals to the opposite side to the angle x over the adjacent side of the angle x. Now these are the three trigonometric ratios which you should know by heart. So I'm going to write down in beige color right in front of those, which are the alternative formula which many of you may have memorized it that way. So cos of the angle x, many students may have memorized as base over the hypotenuse, and tan of the angle x, many students may have memorized as perpendicular over the base. Well, I'll be using in my lesson these terminologies, so you should be able to relate that perpendicular is going to be the opposite and base is going to be the adjacent. The hypotenuse, as you can see in both the formulas, is exactly the same. Now how do these formulas basically work? So let me just draw a triangle here, and it's a right angle triangle. Now the very first thing which again you can say one of the mistakes which I see, these trigonometric ratios, you see this angle x, it will not be a 90-degree ever. So I'm going to put that back at the back of these three trigonometric ratios, that x is never equals to 90 degrees. So basically these three trigonometric ratios, they are not designed for this 90-degree angle. They are designed for the other two acute angles inside a right angle triangle. So as you can see, in a right angle triangle there are three angles. One of them is always going to be a 90-degree angle, so and the other two are, they are always going to be acute angle, means they will be less than 90. So we will be using these three trigonometric ratios on either of these two acute angle triangles. So for example, if I say this is the angle x, so if I name, if I just give random names to the sides of this triangle, let's just say if I call it as A, B and C. Now according to these three trigonometric ratios, sine of angle x, now let's just rewrite these formulas. Sine of angle x, I should know that sine of angle x is always equals to the opposite side to the angle x. So the opposite side in this case is b, as you can see here, opposite. So it's going to be b over the hypotenuse. We've just talked about hypotenuse. Okay, let's just tag the hypotenuse here. Hypotenuse is the longest, or it is the one opposite to the 90 degrees. So in this case, the hypotenuse is going to be A. So this is how you're going to create your equation and work your way out. So sine, and exactly the same way, if I want to know the value of cos of the angle x, cos of angle x is equals to the adjacent side to the angle x. Adjacent means beside, बिल्कुल उसके साथ. So if you look carefully, this is the angle x. Now there are two sides adjacent to angle x, this one and this one. I have already tagged this side as a hypotenuse, so I'm not going to go even near that. So we are only left with the option C. So angle x is going to be C over hypotenuse is A. And finally we have the third one, which is going to be tan of the angle x. That is going to be opposite over the adjacent sides. With respect to the angle x, opposite side is B and adjacent side is C. So that is going to be B over C. So remember, in the same triangle, if you switch the acute angle, so right now I have derived these equations based on this particular acute angle. The moment I moved or switched to this particular angle, the opposite side becomes C. So wherever we are going to use the opposite terminology. So for example, the sine of angle x is opposite over the hypotenuse. So sine of the angle with respect to this angle is going to be equals to opposite, which is C over the hypotenuse A. So the moment you switch the angle, the trigonometric ratios, they are going to give you a different formula. So this is, you can call this angle as a reference angle, which is important in order to work out your equation. So reference angle in a trigonometric ratio, that is important. And as I stated earlier, we are never going to use a 90-degree as our reference angle. So these are the three trigonometric ratios which we shall be using in our formula. In order to memorize these three trigonometric ratios, there is a mnemonic which you can remember, that SOHCAHTOA. People call it as SOHCAHTOA. So each letter in this mnemonic refers to the initials of each term of these three trigonometric ratios. Let's just talk about the first one. So sine of the angle, so sine is to S, O is to opposite, and H is to hypotenuse. So this gives you the trigonometric ratio. Sine of the angle equals to opposite over hypotenuse. This gives you cos of the angle equals to adjacent over hypotenuse, and same for the last one, tan equals to the opposite over adjacent. Those who are memorizing or they want to practice with these formula, they have another very famous mnemonic that some people have curly brown hair through proper brushing. They can stick to that mnemonic and work out their formulas accordingly. So these are the three trigonometric ratios which we shall be using. Now, another important thing here is about the relation of acute and obtuse angle. When it comes to sine of angle theta, actually I will use the term acute instead. So sine of any acute angle, it is always equal to its obtuse part. Now, how would you get the obtuse part of any acute angle? You simply subtract that from 180. So for example, if I have 40 degrees, now clearly this is an acute angle. Now, if I try explaining this concept on a straight line, so this, and if I draw another line which is a little oblique, now this angle over here is 40 degrees. Now this is going to be the acute angle. Now the one on the other side is going to be the obtuse angle, so it is its obtuse part of that same angle. So this is going to be 180, take away 40, that is going to be 140. So exactly in the same way, if you want to work out your acute angle from the obtuse angle, so for example, if you're not provided with the acute angle, you're just provided with the obtuse angle and you want to know its obtuse part, you're going to follow the same procedure. You're going to subtract 140 from 180 in order to get 40 degrees. So this was the concept about acute and obtuse. Now coming back to the concept which I was explaining here, so whenever, now the sine of the acute angle is always equals to the sine of the obtuse angle. I'll quickly prove this on the calculator so that it can justify. So for example, I have sine of 40 degrees, so and I hit equal, you can clearly see it's 0.64. actually I will have its exact value. Now it's not giving me its exact value. Okay, actually let's use sine of 30 degrees. It is going to be 1 over 2. So sine of 30 degree is an acute angle. Now it's obtuse, as I stated earlier, 180 minus 30, which is going to be 150. So sine 150 will also be equals to 1 over 2 according to this relation which I just explained here. So there you go, you have 1 over 2. So if you know this relation, you will be easily able to work out the acute and obtuse relations. This part of the lesson is very, very important for O-level students. Okay, the next thing is the same idea, but this time with the cos of the acute angle is also equals to the cos of its obtuse, but with the opposite sign. Okay, so for example, if cos of one acute angle is positive, the cos of its obtuse angle is going to give us the same value but with the negative sign. So let's just work out the cos of 30 degrees. Now that is root of 3 by 2. So its obtuse part is 150. So if I work out cos of 150, it is going to give me square root of 3 by 2, but with a negative sign. So let's just work that out and see if it's true. So cos of 150 degrees is equals to negative root of 3 by 2. So these two formulas, they are important. I'll talk about these in a minute, specifically for O-level students, because when in their paper 1 where the calculator is not allowed, they do get questions which are in which you have to use this idea in order to work out your solution. All right, now this was about the right angle triangle. So these are the two techniques for the right angle triangles: Pythagoras theorem and trigonometric ratios. Now moving towards the non-right angle triangles. Non-right angle triangles, as I stated earlier, you have two techniques. One is sine rule. People call it as sine law as well. Both are correct terminologies. Okay, now the sine rule, I'm going to draw a structure of the sine rule. Basically, sine rule is a name of a ratio that is basically based on a side and the angle opposite to it. So if you want to work out your angle, okay, if you want to work out your angle by using the sine rule, so you will be using this formula. So sine of that particular angle whole divided by its opposite side. That's it. That's the basic formula, or you can say basic structure, the basic ratio of the sine rule. And exactly in the same way, if you want to work out your side, you're going to use the formula, that particular side which you need to find out, divided by the sine of the opposite angle. Now by the look of it, these two things look very different, but if I try to explain this on a random triangle, so for example, let's just say I have this angle side A and this angle as capital A. Now if I try to develop the ratio for this one, so according to this, sine of the angle A, so sine of the angle A over, now the side opposite to it is A, small a. So there you go. So you have the ratio. And if I move on the right hand side, if I want to start my way out, start working from the side itself. So it is going to be small a in the numerator. In the denominator, you're going to have the sine of the angle A. Now make sure while using this formula, this trigonometric function sine goes with the angle only. Do not apply on the side. Many students, they know the formula, they know the concept, but once they are attempting the paper in rush or in a panic situation, by mistake they apply the sine with the side of a triangle, which gives you very wrong answers. Okay, now this is the sine rule. By using this basic concept, we shall be developing an equation. So every time we will be using sine rule, either for angle or by side, we will be creating two similar ratios and we will be equating them. So basically the idea of the sine rule is that the ratio of the sine of the angle to the side is applicable for one triangle for all the sides and for all the angles. So this over this will be equals to this over this, and that will be equals to this over this. So if you're getting confused with the last part of the information I gave you, don't worry about it. When we move to the questions, you will have a better idea what I'm talking about. So this is basically the sine rule. That's it. No need to dig deeper inside it. Okay, next is cosine rule. All right, now cosine rule is, you need to, okay, now there are basically in your book there are 6 formulas written for the cosine rule. I will tell you just one formula, and that is not actually a formula. I would rather say the structure of the formula, and the structure is based on the relation with the sides of the actual triangle. So for that purpose, I'm going to draw a triangle, and I'm going to name the triangle randomly, and then later on I'll draw a triangle with the names which the most of the formulas are designed for. So for now I'm not going to use standard formulas or the standard names, so that I can explain you the flow of the formula here. So let's just name the triangle sides of the triangle as P, Q and R, and the angles of the triangle as angle P, Q and R, and the sides as X, Y and Z. Now the cosine rule works in a way that you need to start from one of the sides. So for example, if you start from X, so let's just assume we are starting from the side X. So I'm highlighting that. So remember, so follow me here. So the side you start from, take a square of that. So the square of the side you start from is equal to. So the rest of the part of the formula will be on the right hand side of this formula, this equation, okay? So on the left hand side is going to be the square of the side from where you're starting. So if you're starting from Y, on the left side you're going to have Y squared. If you're starting from Z, on the left hand side you're going to have Z squared. In this case, I took a start from X, so on the left hand side you're going to have X squared. Now follow my words and see how I create the formula. So, and if you remember it this way, it will be very easy for you to generate the formula in exam, because in exam, examiner is not bound to give you the triangle with standard names as per the formula which you have memorized, and he's not even bound to name the sides or the angles. So I have seen questions where the examiner has no names for any of the angles or the sides, and he just asks you to work out a particular side. So follow my words and see how I generate the formula. Let's begin. So the x squared, so basically the side from where I'm starting, the square of that is always equal to the sum of the square of the remaining two sides, which you can clearly see is y and z. So you can go for y squared plus z squared. Okay, so just like Pythagoras theorem here, kind of. Okay, so the side from where you take start from, the square of that equals to the sum of the square of the remaining two sides minus, okay, I'm going to use the parentheses in the real formula, or the formula which you may have studied. You may not have seen these parentheses, but I'll tell you the reason why I'm using these brackets here. So inside the bracket, I'm going to go for 2 times the product of the remaining two sides again. So I'm not going to talk about this side anymore, from where I took a start from. That's there. Now the square of the side from where I take a start is equals to the sum of the square of the remaining two sides minus 2 times the product of the remaining two sides, so y and z. And then as we're doing cosine rule, so we will have an involvement of cos. Now cos of what angle? Okay, now that's an important point here again. So whichever side you took start from, the angle right opposite to it. So in this case, it is going to be angle R. So there you go. You have your cosine rule designed and ready to use. Now this shape of the formula which you see in the screen is suitable if you want to work out any particular side of a triangle. If you want to use cosine rule in order to find out the angle of a triangle, so in your book, as I stated earlier, there are 6 formulas written, 3 for each side and 3 for each angle. So you don't have to memorize all those 6 formula, just memorize one with a proper flow. Once you have that, then I'm sure you have studied algebra, and if you're good with your algebraic manipulation, you should be able to make this cos of the angle R the subject. Now here comes the reason why I use these parentheses. I've seen students, what they do is they work out, they calculate y squared plus z squared minus 2 times y times z together in the calculator and leave out the cos of the angle R if they want to find out the angle R, which is a totally wrong calculation. Why? You cannot, okay, over here y squared plus z squared, that is fine because you're adding up the two terms. Now if you look carefully, let me just highlight the different terms here. This y square is one term, z square is another term, and finally we have this 2 times y times z times cos of the angle R. That's one term. If you recall your basics, the terms, they are separated by plus and minus sign. So you cannot add just 3 of the factors of this entire term with these two. So you cannot sum them up. So that would be a very wrong idea. So that is why I always recommend, to avoid these type of mistakes, to use these parentheses. Even if you don't put these parentheses, the formula would be correct, but these parentheses work here as a protection. They save you from making a mistake. So let's just erase these highlights here. Now I'm going to make the cos of the angle R subject here in a minute, but before that, let's just quickly make another formula for y. So by using the same flow, so y squared, the side from where you're taking a start from, is always equals to the sum of the square of the remaining two sides minus 2 times the product of the remaining two sides times cos of the angle opposite to the side where you started from, which in this case is angle Q. So that's an angle Q there. So exactly in the same way, let's just quickly make the formula for z. So z squared will always be equals to the sum of the square of the remaining two sides minus the 2 times the product of the remaining two sides times cos of the angle opposite to the side from where you took a start. So there you go. So you have your 3 formulas for the cosine rule. Now finally, let's just talk about the formula, the cosine rule, if you want to use the cosine rule for your angles. So I'm not going to help you memorize the formula for the angles, because that's, I would rather say, it's a cognitive load. There is no need to do that. Just remember the flow of this formula. How does that work? So you see, just by memorizing that, I was able to generate the 3 formula. Now for example, if I want to work out the value of the angle Q, so I know angle Q will be involved in the cosine rule if I take a start from y. So I will write down the formula like this. So let me just copy that down. So I'm going to copy that down. There you go. So I've written down the formula which has the involvement of the angle Q. Remember, in the cosine rule, the angle of the cos of the angle is the one which from the angle opposite to the side from which you started. Okay, so it always works like this. Now here, let's just say if I want to make the cos of the angle Q the subject. Now look at the benefit of these parentheses. Now this is one term. Now this entire term is negative. Now this entire term moves to the left of the equation, okay, and becomes positive, and this y square, that is one term, will move to the right and will become negative. So you will eventually have 2 times x times z, and then into cos of angle Q, which is moved to the left with the positive sign, is equals to x squared plus z squared and then minus y squared. So what I've done is moved this term to the left, so it was negative here, it is positive here. y square to the right, it was positive here and it is negative here, you can clearly see. Or you can memorize it this way, that swap these two, just you can work that out. Okay, now you can easily see it's very easy to make cos of the angle q the subject here. Cos of the angle q would be equals to x squared plus z squared minus y squared over 2 times x times z, and q would be equals to finally the cos inverse of this entire fraction. So it just involves one more step for, like, basically you write down the main formula, and one more, in one step you will actually reach the required cosine law formula for the angle. So there is no need to memorize the formula for the angle separately. So this is called cosine rule. Now in a question, it's very rare that examiner tells you that which rule you have to use. So for example, he is giving you the question to solve a triangle. You look at the triangle, it's not a right angle triangle. Now you're in a fix that which of these two I shall be using. You know that it's not a right angle triangle, so either I will be using a sine rule or I will be using a cosine rule. Now the problem is which one of these two I shall be using. So for example, if the question actually is solvable by using cosine rule, and you have already but by mistake or unknowingly you started off with sine rule, you have utilized more than half of your space and then realized, oops, you cannot solve this question by sine rule, so you will cross that out. Definitely you will be attempting that with pen, so you have wasted your enough space. Then you will be moving to the cosine rule. That leaves a very wrong impression on the examiner. So here I'm going to give you a very small 4 bullet points which will help you. If you memorize this table, it will help you to decide right after looking at the triangle, without any thinking process involved, that what rule will you shall be using here. So basically on the left I'm going to put sine rule, on the right I'm going to put cosine rule. So 2 bullets for each. Okay, so the collectively 4 bullet points. Now these bullet points which I'm going to give you down here, they are based on given information, they're not based on what you need to find out. They're totally based on what's given in the question. Okay, what data you already have. So whenever you have two angles, so in a triangle, if you have two angles, so technically you have three angles, because if you know the two angles, the sum of the two, if you subtract them from 180, you will always have the third. You can easily have the third angle. So two angles or three angles along with one side. So whenever this is the situation on a triangle, you will always be using a sine rule. And for cosine rule, whenever all three sides are given, you will be always using cosine rule. Okay, now that's one each. Now the second bullet point for both of these, so whenever you have two sides and a non-included angle. Okay, I'll talk about the included angle and a non-included angle in a minute. Okay, so you will be using sine rule whenever you have two sides and a non-included angle, and whenever you have two sides and included angle, then you will be using the cosine rule. Now you see here, this is not two sides with non-included angle, then sine rule. And when it's the opposite of this, which is two sides, here it was non-included, here we have included. So two sides and included, you will be using cosine rule. Now what's included and non-included angle? So for example, I'm talking about these two sides here, A and B. Now let's just mark the angles as P, Q, R. So if I am referring to these two sides, so when I'm saying two sides, then the angle exactly between these two sides is referred as included angle. So the angle included between the two sides I'm referring to. Non-included angle is going to be the one which is not between these two. So in this case, if I'm referring to these two sides, angle Q and angle R, they are non-included angle because they are not between the side A and B. So this is the chart, which is going to help you. Now, how it is going to help you, if you find it difficult, first of all, if you can memorize this, excellent. Now, the best way to memorize it, all right, here is a bonus tip, how to memorize this. So if you still struggling with decision of how to select between the two rules, now once you have, next time when you will be practicing the sine rule and cosine rule, so please have this chart right in front of you. Every time you come across a new question, have a good look at this chart and then decide. So after 5 to 10 questions, and after 5 to 10 questions, making sure you've used all of these 4 criteria multiple times, I'm pretty sure you'll be good to go. Then you will have half, like more than 70% time, like this formula will be in your head. Okay, now this was cosine rule. So we have studied basically a quick recap. So whenever you come across a question in exam, the first thing which you're going to do is check if the triangle is a right angle or a non-right angle. If it's a right angle triangle, then you apply Pythagoras theorem or the trigonometric ratios. If it's a non-right angle triangle, then you apply sine rule or the cosine rule. Okay, so these were the two main informations here. Okay, now moving on towards the ambiguity of the sine rule. Now, sine rule has a problem. But before that, actually, I'll talk about the area. If you can just bear with me for a minute, it's my dad calling. You can take a break for 1 second. Hello, Assalamualaikum. जी 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 Okay, so okay, now let's just talk about the areas of the triangle. Area of triangles. Now there are two formulas for the area of triangle. One is half times base times height, and the another formula is half times the product of the two sides times sine of included angle, which is referred as 1/2 sine AB sine C if you have read the formula from the book. So as I stated earlier, I don't like to use standard names because memorizing the formulas with standard names, somehow you skip the relation of the formula with the actual diagram. So in these formulas, it is important, you need to know that when the examiner is using a particular term A, then what is that A in the triangle. So if you cannot do that, then I would suggest memorize these two, the formulas which I am writing it down here. So half times the product of any two sides times sine of the included angle, means the angle between the two sides, which you will be multiplying here. Now, the very first formula which is written here, there is hidden information about these two sides which is not very apparent in the over here, and not many people know about that information. Base times height, okay, fine, that formula is makes sense, but base and height, base and height should be the two sides which are perpendicular to each other. They must have a 90-degree angle between them. So that's the hidden information. Base and height should be, that's very important, so I'm writing it in caps, so should be perpendicular to each other. If they are not, then that's a problem there, then you will not be able to use this formula. Okay, so now, having said this, there is a myth about this formula that you use this formula only for right angle triangles, which is again wrong, not necessary. So I'm going to draw two triangles here. this is a right angle triangle clearly. Let's say this is 10. Actually, this is 3, this is 4, and this is 5. Okay, and another triangle here. Let's say this one. This is 10, this is, let's say, 7, this is 6. I'm not sure even if these three sides they make the actual triangle or not, but this is just for the idea of the formula. Now this formula gets easily applied on the right angle triangle. It's not that it's only for the right angle triangle. This formula gets easily applied on the right angle triangle, because in a right angle triangle by default you have the two sides which are perpendicular to each other, which in this case is this one. So even if the right angle triangle is drawn this way, then one of them you can take it as base and the other one you can take it as height. So as I stated earlier, do not memorize the standard name. So base doesn't have to be the side on which the triangle is standing. Okay, so it could be any side. You can take this one as base and this one as the height of the triangle, because in reality you can rotate the things. Okay, all right, so that's the hidden information about this formula, that the two sides, they have to be perpendicular to each other. If they are perpendicular, then you can apply this formula very easily and directly to the given triangle. Same goes for this one. So as you can clearly see, the two sides by default, they are perpendicular to each other. But if you have this type of question, the second triangle in which I have taken sides as 10, 6 and 7. Now if you apply the formula, the same formula here as 1 over 2 times 10 times 7, then that would be totally wrong. Because yes, you can take this as base, but you cannot take 7 and 6 or 6 as the heights of this. The height has to be perpendicular. So until and unless the vertical height, which is perpendicular to the, although even if it's not there, so I'll rather use a dotted line. So this is an imaginary height, okay, or you can call it as imaginary line, vertical line. So this is the height. So it's just like you may have seen Simba cartoons. There was a hill where the Simba was introduced by that monkey. Now the cliff was designed like this. Now the height of the cliff was not this distance or this distance. The height of the cliff is going to be this one. Now apparently there is no physical wall of the rock which is all the way down to the floor, but whenever you need to work out the height of this cliff, this is how you're going to work that out. Okay, so that is the vertical height of this triangle. So that the reason I've used the dotted line is not actually a part of the triangle. It's not the real lines. It's just imaginary vertical distance. Now this is going to, if you have enough data to work out the perpendicular height, or it's given, then you will be using this formula. So if you want to use this formula in order to work out the area of this triangle, then base is going to be 10 and the height is going to be this length here. So this was about this formula. For this one, you can use this formula on any triangle. On any triangle. Having said that, when you're multiplying the two sides which you're multiplying, you should have the angle, the one between those two angles, those two sides. If you do not have the angle between those two sides, or if you're using the wrong angle, like you're using a non-included angle, then this formula will not give you the right answer. Okay, now moving towards the ambiguity. Now this was the area of the triangle. Now here is an important part, which is ambiguity of sine. It's not, the ambiguity is not there all the time. So you can say there are confusion or multiple answers while using sine. So up till now we have used sine, trigonometric ratio, like the trigonometric function sine, at 3 different places. So I'm just taking you to the back. We have used sine here. We have used sine in the sine rule. And we have used sine in the area formula. So there are 3 places. So trigonometric ratios for the right angle triangle, then sine rule, and then area formula. So we have used sine, we'll be using sine in these three particular locations. This ambiguity does not apply on trigonometric ratios, so you don't have to worry about that. The only ambiguity involving a sine rule you can come across with, it's not necessary you will always get that, but sometime that will be while using sine rule or while using the area formula. Now I'm going to list down the types of the question, and the ambiguity comes in when you're supposed to find out the angle. So that ambiguity is basically while finding angle. So you can be, the examiner may ask you to find the angle using sine rule, or he may have given you the area of the triangle and he may ask you to work out the angle between the two sides. So while finding angle. So the ambiguity of the sine rule is, I'm going to list down the three types of question. The first one is straightforward question where there is no ambiguity. So no ambiguity, straightforward question. Examiner will ask you to find out the angle, so you simply work out your angle. Normally you would do it by sine inverse of whatever that is. Okay, the second is, examiner will ask you two possible angles. So examiner will ask you for two possible angles. Now how does that work? Now that takes us back to the concept which I stated for only O-level students. Like, it was not like only for O-level, but I was said it is very important for O-level. As you can see, sine of acute and sine of obtuse are exactly same. Okay, so for example, if you're using sine, if you want to find out the angle x, and this is how you will be doing. So sine of the angle x, so sine inverse of 1/2. So here I'm trying to find out the angle. As you can see, the calculator is giving me 30 degrees. So basically, according to the calculator, sine of 30 degrees is 1/2. Sine of 30 degrees is 1/2. But we know sine of 150 degree is also 1/2. What if the situation inside the triangle is such that it could be 150, it could be 30? So the calculator will never give you the obtuse answer. So that is why it's saying two possible answers. So whenever the examiner asks you for the two possible answers, one answer would be the acute angle which the calculator is going to give you. Another answer is going to be, so one answer would be acute, another answer would be obtuse. So I've already discussed how to work out the obtuse. So 180 minus 30. So you will write down both the answers as your final answers. Third is, examiner only asks you to write down obtuse. So here, this is where the problem is. The many students, when you come across this question where the examiner asks you two possible angles, so many students, it clicks in their mind, okay fine, we need to work out the obtuse here. But if I ask you just for the obtuse, many students they do not focus on this, and they somehow forget about the ambiguity. Now they by default, and they simply just work out this, and they say, okay, 30 degree is the answer, and they write down 30 degree. Now they cannot relate 30 degree is an obtuse. So examiner does not want 30 degree as in your answer. So he wants just the obtuse part of it. So once you have your answer from the calculator, all you have to do is simply subtract that from 180, and that is going to give you 150. So simply give your obtuse angle as your final answer. So these are the three possibilities when it comes to the ambiguity of the sine rule. Now, last part of the trigonometry. Trigonometry is a very huge section, okay? Last part of the trigonometry is bearings. But in bearings, you need to remember two rules. One, whenever you come across the bearing question, always start looking for the north, because that is going to ultimately save you. So start from the north. Once you locate the north, you need to move in clockwise direction towards the stated point. Okay, so for example, while I'm standing here, I'm facing towards the camera, so I suppose this is my north. So for example, the examiner wanted to ask me about the location of something which is on my left. So he's going to ask me find the bearing of that thing. So what I'm going to do is, wherever I am facing, the first thing I'm going to do is I will face towards north. Once I am facing towards north, now although if I move in a clockwise direction, that's the short way, but I need to follow the rules. So I need to follow the according to the rules. I will move in the clockwise direction. I will go all the way around in the circle until I face that particular thing. So this is how it works. And finally, that's how you write down the bearing. So before decimal, it's always 3 digits. So for example, the bearing you worked out is 44.3. So in your final answer, you will not write down 44.3, you will write down 044.3 in order to make 3 digits before the decimal here. So this is how the bearings work. In bearings, we will be using two concepts here. Whenever you see a C shape, so a C shape formed by two parallel lines, remember the relation between these two angles. They both are supplementary, means A plus B, they will always add up to 180 degree. Now this is the very important concept here. We'll be using this a lot. Now this is basically the angle fact. Whenever you have two parallel lines, the angles inside here, they are known as allied angles. They always add up to 180 degrees. And another concept which we may be using a lot would be the Z shape. So for example, I have two parallel lines and I see a Z shape being formed there. So a Z shape angle is this one. So these angles are going to be same. So let me just point out the north direction there. So these two concepts we shall be using in the bearing. So this is it, beta. This was the complete revision of the trigonometry. Now let's just jump to the worksheet. Okay, I've opened the worksheet of structured questions. I hope it will help you to understand the concepts easily. So I'm going to start off with a question where we have right angle triangles. Okay, we have a question where we have a right angle as well as, no, not this one. There you go. Let's just do this one. Okay, now question number 52, you should be able to see on the screen. In a pentagon ABCDE, now this is the entire pentagon ABCDE, angle ACB, angle the one in the middle is C, so they're talking about this angle connected with A and B, so this is 90 degree, and angle AED, so the in the middle it's E, which is connected with A and D, so that's also 90 degree. The triangle ACD is an equilateral triangle. Okay, as I stated earlier, equilateral triangle, so each angle is going to be of 60 degrees here. So just mark down the known information and which is not in the diagram, so it always helps you. With side length of 12 centimeters each, so you can clearly see 12 is written on CD but it's not written here, so I'll write it down here. It may be helpful. Okay, DE equals to BC. Yes, another information that these two lengths are equal, so I'm going to mark, I'll give two markers for those, because in order to differentiate from this one marked side, so I'm going to give 2 marks for it. So why 2? Because they both are same. Okay, calculate the angle BAE. Okay, BAE, the examiner wants you to work out this entire angle here. All right, now we need to work out this entire angle there. So for that purpose, we need to know this angle and this angle, and then we will add up all these angles. Now if you look carefully, this is 6, this is 12. Okay, this is 6 and this is 12. Now first thing first, many students will perceive that these two angles are exactly same, which is wrong. This angle here is between a hypotenuse 12 and AE. Over here the hypotenuse is not 12. If it would have been hypotenuse 12 and the other side, then I would have concluded that these two angles are same. So if I try drawing these two angles side by side, so one is AED, the one on the top, 90 degree at E, DE is 6, and in that one AD is 12, so that's the hypotenuse. One at the bottom you have ACE, and B, 90 degrees at C, BC is 6 and AC is 12. Now clearly the two triangles, they are not going to be same, because if this is 12, then I would say that the two triangles are same. Then I could have concluded that these two angles are also same. So let's just use these two triangles separately and work out the required angles. So first of all, for angle BAC, which is basically this one. So if you look carefully over here, so I'm talking about this angle here. So this is going to be my reference angle. So this is a right angle triangle. I need to work out the angle. I cannot use Pythagoras theorem here. So I'll be using trigonometric ratios here. Now the trigonometric ratios are these three. So let me see if I can pull these on a side. Yes, I can. There you go. So I have three trigonometric ratios here: sine, cos, and tan. Now according to this reference angle, let's see what information do we have. We have the side opposite to it, and we have the side adjacent to it. This is hypotenuse. Okay, so opposite and adjacent. If you look at the formulas on the left, you should be able to see that the combination of opposite and adjacent is in the formula of tan. So we'll be using tan. So tan of the angle theta is always equals to the opposite over the adjacent. Now I'm going to plug in the values. So tan of the angle A in this case would be equals to, opposite is 6, adjacent is 12, and A would be equals to tan inverse of 6 over 12. So tan inverse of 6 over 12, and the answer is 26.57 degrees. So I'm sticking my for now I'm sticking to two decimal places, because this is not my final answer. So 26.57, so 26.57 degrees. Now exactly in the same way we will work out for the triangle DAE. For the angle DAE, now in this case, this is the angle which we need to find out. Now this angle, with respect to this angle, we have the opposite side and we have the hypotenuse here. So opposite and hypotenuse, if you look carefully, the combination of opposite and hypotenuse is in the sine formula. So I'll be using sine of the angle theta equals to the opposite over the hypotenuse. So let's just plug in the values now. So sine of the angle A in this case would be equals to, opposite is 6 and hypotenuse is 12, and A would be equals to sine inverse of 6 over 12. So sine inverse of 6 over 12, and that's 30 degrees. Okay, so this is 30 degrees. So now finally angle BAE would be equals to 26.57 plus 60 plus 30. So 26.57 plus 60 plus 30. If you add them up, you should be able to get 116.6 degrees correct to one decimal place. So this is your final answer for this question. Okay. Now the next thing is calculate AE. Now we need to work out the value of AE. AE, if you look carefully, is a part of a right angle triangle up here. This one. So we'll be using this triangle. So I'll copy it down. Oh, I skipped through question. So the part 2, let's just do that. Calculate AB. Okay, for AB we'll be using this triangle, right angle triangle. So again we're still using right angle triangles here. Okay, AB is the hypotenuse which we need to find out. I have the two sides. I don't have to use trigonometric ratios. So whenever you have two sides, I can use Pythagoras theorem. So hypotenuse squared, which in this case is AB squared, is equals to the sum of the square of the other two sides. So AB would be equals to the root of 12 squared plus 6 squared. So root of 12 squared plus 6 squared, and this gives you 13.4, correct to three significant figures, 13.4 centimeters. And then finally, let's come back to this one. We need to work out the value of AE. Again, we have the two sides given. We need to work out the third one. So we don't have to use trigonometric ratios here. We will be using Pythagoras theorem. So according to the Pythagoras theorem, hypotenuse squared is equals to the sum of the square of the other two sides. So 12 squared would be equals to 6 squared plus AE squared. AE squared would be equals to 12 squared minus 6 squared, and AE would be equals to the root of 12 squared minus 6 squared. So the root of 12 squared minus 6 squared, this gives you 10.4, correct to three significant figures. Calculate the area of the pentagon. So in order to work out the area of the pentagon, so don't get panicked that we don't know the formula of the pentagon. You will be calculating the area of the three triangles separately and then work your way out. So let me just quickly scroll down to the area section. There you go. So if you look carefully, you have two right angle triangles. So you know by default we can use the first formula, which is base into height on the right angle triangle. So let's just work out the area of the triangle ABC. So in that one, base is 6 and height is 12. So I'll be using this formula. So 1 over 2 times 6 times 12. So 1 over 2 times 6 times 12. So that will give you area of the triangle ABC. Okay, so that will give you 36 centimeters squared. Okay, now next, another right angle triangle is this one, AED. In AED, this is the one. We have the base, we know the 12, but this is not the perpendicular side. So the perpendicular side is AE, which we have worked out as 10.4. So let me just put that down. So for this one, we will, the triangle area of the triangle AED would be equals to half times 6 times 10.4. So that is going to give you, half times 6 is 3. So 3 times 10.4 will give you 31.2 centimeters squared. Finally, the area of the triangle which is between them, which is clearly not a right angle triangle, so the area of the triangle ACD. Okay, now for that one, I cannot use half times base times height, because for example, if I consider this as base, I do not have a perpendicular length to it. So if I want to work out the perpendicular length, I can use trigonometric ratios here. For this right angle triangle, I have 60 degree. I know this is 12. I can work out the opposite, which is the perpendicular. So sine theta would be equals to opposite over the hypotenuse. So that's a long shot. So let's just stick to the other formula, which is half times the product of the two sides times sine of the included angle. So I know all the sides here and I know all the angles. So let's just use these two sides. So 12 times 12, and the included angle is 60. Okay, so half times 12 times 12 times sine of the angle 60 degrees. Now if you put this in your calculator, so half times 12 times 12 times sine of the angle 60 degrees, and this is going to give you 62.35 centimeters squared. Now that's the area of the three triangles separate. Now the total area, that would be equals to 36 plus 31.2 plus the previous answer, and that is 129.5, which is correct to three significant figures, 130 centimeters squared. Now here is a quick tip for you guys. Sometimes, now what happens if your calculator is in your bag or just by mistake, the mode of the calculator gets changed. On your top of the calculator screens, you should be able to see a very tiny d written. So for example, this is the screen of your calculator. You should be able to see a very tiny d written here. That means your angle the unit of your angle is in degree mode. So this is how it should be, this is how it is supposed to be. But somehow by mistake, so for example, if one of your siblings or even just in your bag by mistake some button get pressed up and your calculator changes to the radian mode, so if your D changes to R, so what happens, I'll be doing the very same calculation here. So let's just say I'll be doing calculation for this one. Okay, or actually let's just do the basic one where I had 30 degrees as an answer. This was this one, sine inverse of 6 by 12. So I'm going to do sine inverse of 6 over 12. At this time my angle is in, look at the answer. So I've done the exactly same calculation, so I'm going to change it back to the degree mode. I'll do the same calculation one more time. So 6 over 12, and the answer is 30 degrees. So previously it was 0.5 something, now it is 30 degrees. So zero point 0.5. So if it's in radian and if it's in degrees, it's 30 degrees. Now it's always healthy whenever you walk into your examination room, make sure you reset your calculator. On your calculator screen, if you press shift, clear all it, and then follow the instructions through, then it will help you to reset your calculator and once you reset your calculator, by default it is in degree mode. And if you do not know how to change it back to the degree mode, go to the mode section or the setup section and go to the angle option and then change it to the degree mode. So we have done one question which was about the right angle triangles and the area. This was a good question here now. Okay, now question number 53. Let's just do this one. The examiner is asking you to calculate the area of the triangle. So two sides included angle. So simple formula, half times 8.9 times 12.5 times sine of 130.6. I'm not going to calculate this just to save the time. I'm just going to skip through the question here now. Okay, now talking about this one, the first question is calculate the angle BCD. BCD is this angle. Okay, now this angle is a part of this triangle, so I want you to focus on this triangle here. So what information do you have in the given triangle? Now this is not a right angle triangle, so clearly you will not be using trigonometric ratios or a Pythagoras theorem. So you have to use either sine rule or the cosine rule. So let me just open up the chart here. Now that's the chart here. I hope it's too tiny, but okay, let me just split this to 50-50 view so that you can have a better view here. Actually, for now I think this would do the job. So in this triangle on the right, if you look carefully, you have two sides and a non-included angle. So two sides and a non-included angle. If you look carefully over here, this is the second bullet of the sine. So you will be using sine rule in order to attempt this question. Okay, so switching it back. So using sine rule. Now I'm going to take you back to the main formula of the sine rule, which was here. Now we need to find out the angle. As I stated, if you want to work out the angle, you'll be using this one, and if you want to work out the side, you'll be using this one. The both are same, it's just the unknown quantity gets in its place in the numerator. Now if you want to use this find out the sine angle here, we need to work out the angle, so I'll be using this one. So sine of the angle, so sine of the angle, so let's just create our formula. So sine of the angle C, that's the unknown angle here, sine of the angle C divided by the opposite side. Now if you look carefully, the side opposite to this angle is 11.6. So 11.6. So that's one ratio. If you recall from the beginning of the lesson, I told you that you need to create two such ratios and equate them. So equals, I will be creating exactly same ratio for another pair of the angle and the side, opposite pair of the angle, opposite angle and side. So where let's look for another angle and the side which are opposite to each other, but making sure that both are known to you. So this angle, if you look carefully, this angle and the side opposite to it, both of these they are known. Why they both have to be known? Because you already have one unknown quantity on the left of the equation. There should be only one unknown. So sine of the angle 123.5 whole divided by 21.3. There you go. You've applied sine rule. Now all you have to do is, you've done the question. Now all you have to do is simple basic maths in order to make C the subject here now. So sine of the angle C is equals to 11.6 times sine of 123.5 degrees over 21.3, and then C would be equals to sine inverse of 11.6 times sine of 123.5 degrees whole divided by 21.3. Now simply put this in your calculator as it is. So sine inverse of fraction button 11.6 times sine 123.5 bracket close, and in the denominator 21.3, hit equal, and the answer is 27.0 degrees, correct to one decimal place. There you go. Okay, next is calculate AD. So we need to find out the value of AD now. Now AD, if you look carefully, is basically a part of this triangle here. So what I'm going to do is just copy down this triangle. Let me trace it first. So this is 18, this is 11.6. okay, how much this angle would be? Okay, this angle would be 90 minus this one. So how much is this angle? We have worked out this angle, which is 27. So this is 27. This angle over here would be 180 minus 123.5 minus 27. So you take away the two known angles of that triangle, you have this one, 29.5. Now 90 minus 29.5 will give you this remaining angle. So 90 minus 29.5, that is 60.5. So you have this angle here. Okay, now let's just copy down this triangle there. There you go. We have the given triangle now. Now before we proceed further, we need to do a little bit of working. We have, although we have shown that in the diagram, but for the examiner we need to show how we got this 60.5. So in the first step, I'll do whatever I've placed in the calculator, I simply put it down here. So for the angle, okay, I forgot to write down the names here. ABD, this was A, oops, wait a minute, this was A, this was B, and this was D. Okay, the first angle, the first of all, we calculated 29.5, which was angle DBC. So DBC would be equals to 180 minus 123.5 minus 27, which came out as 29.5. Then what we did was we calculate angle DBA, which is this one, that we calculated by doing 90 minus 29.5, which gave us 60.5 degrees. So we have shown our working for the examiner, that how we got to this angle. It is important. Okay, now we will continue our question. Now if you look at the triangle, it's clearly not a right angle triangle. So again, we will not be using trigonometric ratios, we will not be using Pythagoras theorem. So what are we going to use here? Either sine rule or the cosine rule. So again, I'm going to take you back to the same table there. There you go. So there, here you have the table. If you look at the triangle carefully, what information do you have? So we have two sides and then the angle between them, two sides and included angle. So that leaves us with cosine rule. So we shall be using cosine rule here in this question. So cosine rule would be, now cosine rule, we need to find out the side AD. So let me just take you back to the cosine rule where I explained the structure. It was, if you recall, just 50-50 split, so that you can see the formula and the triangle and its relation with the triangle. So if I need to start off with AD, so square of the side from where you're taking a start from, so in this case it is this one, so that is equals to the sum of the square of the remaining two sides, which gives you 18 squared plus 11.6 squared minus, and in the parentheses you put 2 times 18 squared, no, not 18, sorry, it's not squared, so 2 times 18 times 11.6 times cos of the angle opposite to the side from where you started, so that leaves you with 60.5, bracket close. Now in order to work out the value of AD, you will be taking the root of 18 squared plus 11.6 squared minus 2 times 18 times 11.6 times cos of 60.5. Now we do not need to make cos the subject here, so you can get rid of these parentheses. I simply just I'm going to put all these values in my calculator. So root button, inside the root button I've got 18 squared plus 11.6 squared minus 2 times 18 times 11.6 times cos of 60.5. There you go. So this is giving me an answer of 15.9 centimeters. So I'm going to check mark all the concepts which we have already practiced so that we can skip through the questions in the worksheet. So we have done a question of cosine rule with two sides and an included angle. We have done a question of sine rule with two sides and a non-included angle. We have done area questions of both types. We have done the trigonometric ratios. We have practiced the Pythagoras theorem. Now we shall be looking at the questions where it involves sine rule with the two angles given and along with the one side, and the cosine rule with all three sides given, and then we'll be looking into the ambiguous cases of the sine rule, and also we'll be attempting the question which involves the bearing questions. Okay, so here we have a question about the bearing, so let's just do that one. Let me see. Yeah, it's the bearing question. So in order to get to the part of the bearing question here, we need to solve the question from scratch. So I'm going to quickly solve the question here if we have already covered that concept. So the first part is calculate the average speed in kilometers per hour. So let me just go through the information. A plane flies from Geneva to Hamburg. The flight takes from Geneva to Hamburg, so that's the distance, and this is the time. So we need to calculate the speed in kilometers per hour. So distance is 864 over time. Time we need to give it in hours. So we have 2 hours, but we need to work out the value of 20 minutes in hours. So 20 divided by 60, that is okay. So in order to have the exact value, I'm going to write down 1 by 3. So 2 hours plus 1 by 3 hours. Okay, so I'm going to put this in my calculator as it is. So 864, and in the denominator I have 2 hours plus and 1 by 3 hours combined together. So that is going to give me the average speed in kilometers per hour, which is 370. Correct to three significant figures. Okay, next is using cosine rule. Okay, now as I stated, it's very rare that the examiner tells you what rule you have to use, but even if it doesn't tell you, just by looking at the question, if you're supposed to work out the distance from Geneva to Budapest, so that's the distance which we need to work out. So as I stated, that decision of the cosine rule and the sine rule, that is based on the given information. So the given information in this triangle, as you can see, you have two sides and an included angle, which is, we have already done this case, so I'll quickly go through this question and work out the value of the required side. So GB would be equals to 864 squared plus 928 squared minus 2 into 864 into 928 into the cos of angle 67 degrees. I'm doing it directly here, which is not suggested for you guys. You need to show your proper working the way I did it in the previous question. If you look carefully, I directly started off from the step where there is a root on the formula. Okay, so this leaves you with 991 kilometers, correct to three significant figures. The bearing of Budapest from Hamburg is 133 degrees. So the bearing of Budapest from Hamburg. So let's just break down this information, that what does it actually mean? It means the bearing angle of Budapest. So you're talking about the angular direction of Budapest from Hamburg. Okay, so your location is at Hamburg. So while you're at Hamburg, if you are at Hamburg and you face towards north, so this is where you have to be. H stands for Hamburg here, facing towards north, moving in a clockwise direction of 133 degrees will make you face the Budapest. So that's Budapest there. So basically this angle up here is 133 degrees. That is given by the examiner. That's the given information. Find the bearing of Hamburg. So we need to work out the bearing angle of Hamburg from the Budapest. Now we need to imagine ourselves standing at the Budapest. So let's just draw the north while we are at Budapest. Now I'm at Budapest facing towards the north. Now definitely all the norths, they are parallel to each other. Examiner has drawn the north in upward direction of the paper, which is 99.9% of the case. This is how it is going to do. So your north while you are at B is going to be in the same direction. Once you're facing towards the north, start moving in the clockwise direction till you reach here at this point. So this is the required angle which you're supposed to tell here. Now how would you give this angle? Now there are two possible ways I'm going to tell you. One, if you want to follow the C-shape formula, as I stated, the two formulas that here. Now if you look carefully, this is north and this is north. You should be able to see the C shapes here. Now this is 133. How much is this going to be? 180 minus 133. Now this is going to give you an angle of 47 degrees. So basically this angle here is 47 degrees. Why I worked out this angle? Because I need to know this angle. So if I know this angle, I'll take it away from 360 in order to have my required angle. So 360 take away 47, that will give me the required bearing, which is 333. So this is 333 degrees. I took away 47 from 360 degrees. So I'll just do the little bit of working here. So 180 minus 133, that gave me 47, and 360 minus 47, that gave me 313. Now to the final point, that the bearing has to be a 3-digit number before the decimal. It's already a 3-digit number, so I'm good to go. I'll simply copy that down on the answer space. Now the next question is calculate the bearing of Budapest from Geneva. Okay, now he's asking you to be at Geneva, from Geneva. See here, from Geneva. So my current location, I need to suppose myself that I'm standing at Geneva, face towards north. So once I'm there, I need to calculate the angle, tell the angular direction of Budapest. So I'll start moving in a clockwise direction and I need to tell this angle. I should be able to tell this angle if I know this angle. So if I have the information about this angle, I can clearly tell how much is this angle by using simple C-shape rule there. Because in a C-shape, remember, if you know one of the angle, the other angle is 180 minus that angle. So if you look carefully, these two locations, if you try drawing, focusing on the C-shape formed by these two locations, Geneva and the Budapest, this is the required angle. You can easily tell if you have this angle. I can easily have this angle. How? I have this angle, this is 47 degrees, all I need to do is work out this interior angle of the triangle. So basically here we need to involve a little bit of a trigonometry here. So let's just draw the triangle down there. HGB, HGB, and H is 67 degrees, HG is 864, 864, 64, 46. Even yesterday while solving O-levels paper I made the same mistake. It was, I guess, 64 and I copied it down as 46. Okay, HB is 928. Alright, so we need to work out which angle? This one here, which is at B. So this is the angle which we need to find out. Okay, let me just double check if I have any other relevant information. Yes, we have this length as well, which is 991. So I'll copy that down as well, 991. So if you look carefully, I've got two possibilities here. You can take it as two sides and a non-included angle and use sine rule to work out this angle. So let me just there you go. So two sides and a non-included angle, and use sine rule in order to work out this angle. So sine of this would be the sine of angle over this side, sine of angle over this side. So you can easily use the sine rule, or what you can do is you have all three sides given. You can use cosine rule starting from this side so that this angle is involved in your formula to find out this formula. So I'll stick to sine rule because that is comparatively easy. So I'm going to scroll up to the sine rule. Again, we need to find out the angle. So it's easy. Sine of the angle B over the opposite side. So what's the side opposite to the angle B? That's 864. Now I'm going to create another ratio of the same nature where I have the angle and its opposite side both known to us. So sine of the angle 67 degrees divided by 991. So all I have to do is make B the subject now. Sine of the angle B would be equals to sine of the angle B would be equals to 864 times sine of 67 degrees whole divided by 991, and B would be equals to sine inverse of that. So I'll just quickly calculate. So 864 times sine 67, 991, and the answer is 53.37 degrees. So basically this angle here is 53.37 degrees. So 53.37. So these two angles combined together, they will be 47 plus 50, 40, was that 47? Yes, that was 47. So 47 plus 53.37. So I'll add 47 into my answer, and that is, so 47 plus 53.37 is, oops, not here. So basically, if I draw a north here, this angle was 47. So 47 plus 53.37, this gives you 100.37. Now, once I have this, all I have to do is subtract the sum of these two from subtract this angle from 180 in order to have the required angle by following the C shape, this one. As I stated, both of these, they add up to 180 degrees. Okay, so bearing would be equals to 180 minus 100.37. So 180 minus the answer, that's 79.63. or if you just stick to one decimal place, which is 79.6. Now that's the bearing. Now finally, before decimal, we should have 3 digits. So in my answer space, I'm going to write down as 079.6 degrees. Got it? So this is how you shall be working out the bearing. Okay, we have done bearings question as well. Okay, now I'm going to quickly scroll through the worksheet and look for the questions which we haven't practiced as of yet. So, cosine rule. In order to find out the side, we've done that. That's a higher order. Let's just practice the basics first. Okay, now here we have the sine rule in order to calculate the side. So let's just do that now. But wait a second. AB, two angles. Yes, this one. So we have two angles and one side. The first one, two angles and one side. So whenever you have this situation, you apply sine rule. In this case, the examiner has told you himself, but even if he doesn't tell you, you should know two angles and one side, then you will be using sine rule. So let's just find out the value of AB. So this angle side AB, now taking you back to the sine rule here. Now this time I'm not going to use the first one because that was for angle. I need to find out the side. I need to keep the side in the numerator. So side AB divided by sine of the angle opposite to it, which in this case you can clearly see is 85 degrees. So sine of 85 degrees equals 240 divided by sine of 50 degrees. So AB would be equals to 240 times sine 85 over sine 50. 240 times sine 85 over sine 50 degrees. And this is 312. That's it. Correct to three significant figures. 312. ठीक हो गया जी, हमारा ये वाला क्वेश्चन भी हो गया. अब रह गया cosine rule where all three sides are given to us. So I'm going to look for the question where all the three sides are given to us by the examiner. There you go. I can see the triangle here where we have all the three sides. Let's see if the examiner is asking you to calculate the angle. Yes, he's asking you to calculate the angle BCD. This is the unknown angle there, which you need to find out. So if you want to find out this angle here, and you see here, all three sides are given, so you will be using cosine rule. As I stated earlier, while teaching the cosine rule, you don't have to memorize the all 6 formulas for the cosine rule. If you don't know, just stick to the one basic flow. So I'll just split it to 50-50 view. All right, so here I'm going to create the formula according to the situation here. As you can see, I have 3 sides and I need to find out basically this angle here, this one. So I can have this formula, this angle in my formula if and only if I take a start from its opposite side. So I know where I need to take a start from. So 80 squared is going to be equal to the sum of the square of the remaining 2 sides minus 2 times the product of the remaining 2 sides times cos of the angle C. There you go. So you have the formula. Now all you have to do is make C the subject here. Now this is one term as I stated earlier, I've discussed this in very detail in the beginning of this video. So if any one of you have joined us recently, after the video you can go back and see why I'm using parentheses here. So I'll move this entire term there and this one there. So that leaves us with 2 times 90 times 95 times cos of the angle C equals to 90 squared plus 95 squared minus 80 squared. Cos of the angle C would be equals to 90 squared plus 95 squared minus 80 squared, and then whole divided by 2 times 90 times 95, and then finally C would be equals to cos inverse of 90 squared plus 95 squared minus 80 squared over 2 into 90 into 95. I'll simply plug this into my calculator. Shift cos inverse fraction 90 squared plus 95 squared minus 80 squared whole divided by 2 times 95 into 90. Bracket close, and the answer is 51.2, correct to 3 significant figures. Okay, I was supposed to do this down here. Okay, so we have done the question which involves all 3 sides. Now only one thing is left over, which is basically the ambiguous cases of the sine and cosine. So just bear with me while I look for those types of questions. In the meanwhile, you can just take a break. I'm putting on the waiting screen, please. Okay, I found the question. Have a good look at the question. Now this is where the examiner is asking, in the first part, he's asking you to show that the length of the road is 135 meters, road AC. Now AC is part of the 2 triangles here, one up here and one up here. We will see which triangle has enough information. So we can clearly see that the triangle below this one has enough information, which is 2 sides and an included angle, which leaves us with cosine rule, 2 sides and included angle. The second bullet of the cosine. Now I'm going to focus on the part B of this question. Calculate the size of the obtuse angle ABC. Now you can clearly see the examiner has bolded the letter obtuse, so he wants you to focus on this word, okay, so that you don't get this wrong. So the required angle is obtuse. Anyways, the angle ABC, this one here, this is what you need to find out. Okay, for that you do need this side, so I'm going to quickly work out that side AC by using cosine rule. 120 squared plus 95 squared minus 2 into 120 into 95 into cos of the angle 77, and that side is basically 135. Oh, he actually gave it here. It means I'm really tired by now. Okay, calculate the size of the obtuse angle. Now in this triangle, if you look carefully, you've got 2 sides and a non-included angle. So taking back you to the bullets, which one you have to use, because in this question the examiner has not mentioned which rule you have to use, so you should know this table. So the size, in order to calculate the size of the obtuse angle here, if you look carefully at these 2 bullet points, that you have 2 sides and a non-included angle. Two sides and a non-included angle takes us back to the sine rule. So we shall be using sine rule here in order to attempt this question. So I'll actually solve it here in this space because I don't want to keep scrolling up and down. Okay, so I need to work out the angle ABC. This is the angle which I need to figure out. So taking you back to the sine rule formula, which is here. So sine of the angle divided by the opposite side, which is 135, equals to sine of the angle 26 divided by the opposite side, which is 79. Now sine of angle B, this would be equals to sine 135 times sine 26 degrees whole divided by 79, and B would be equals to sine inverse of 135 times sine of 26 degrees whole divided by 79 and bracket close. Put this in the calculator, shift sine inverse, fraction 135 times sine 26 bracket close over 79, and there you go, you have your answer. And you can clearly see that the answer is 48.5 degrees. Okay, now once you know that the answer is 48.5 degrees, now I'm going to take you back to the ambiguous cases of the sine. There you go. I told you there were three possibilities. One where there is no ambiguity, so we have done the question involving sine with no ambiguity. They were pretty straightforward. We simply work out the angle by using the sine rule. So we have done this part. Now this one here, where the examiner asks for two possible angles. Now whatever answer you get from your calculator, you subtract that from 180, and in the final answer space you write both of your answers. But this is the question where the examiner wants you to write down just the obtuse angle. So for that, again, the procedure is going to be still the same. So one more step you have to do. So for obtuse, you do 180 minus the answer. So 180 degrees minus the given answer, which is 131.5 degrees. So this is going to be your final answer, which is clearly an obtuse. So we have done and discussed all the cases of this trigonometry, and I hope it was helpful. Just one last bonus tip for you guys. Sometimes the examiner asks you work out, I can't find the question here for now, but let's just create the question here. Sometimes the examiner asks you calculate the shortest distance from, this is how the statement of the question is, calculate the shortest distance from B to AC. So this is clearly B and this is the line AC. So he wants you to calculate the shortest distance. So that is always going to be the perpendicular distance. So you have to draw an imaginary perpendicular line there. So once you have the line, so this is the length of the line which is required by the examiner. Then if you look carefully, you have a right angle triangle. Many times you will obtain two right angle triangles. Then you have to decide which one of these two have enough information in order to work out the angle X. Here I see another common mistake. Even if the students know that they have to work out the perpendicular distance, somehow they divide this opposite length into two equal halves, which is wrong. That is not possible until unless the given triangle is isosceles. If the given triangle is isosceles or equilateral, then you draw the perpendicular, then whatever the length is opposite to it, then it gets divided into two equal halves. Then you can say this is 2.5 and this is 2.5. But in this case, I cannot say how much is this length because the examiner has not mentioned in this question that if this triangle is an isosceles or equilateral. So I'm going to use this triangle, and with respect to this angle I need to work out the opposite side, and the given side is the hypotenuse. So opposite and hypotenuse, the combination comes in the sine formula. So sine theta equals to opposite over hypotenuse. So from there you can easily work out this shortest distance. So this was one final pro tip for you guys. Hope this helps you a lot. I will share the worksheet along with these notes in the community section. If you think this session was helpful, please subscribe, share with your friends, And inshallah tomorrow, I'm not sure yet if they have announced about the Eid, if it is tomorrow or not, but even then I'm not going to have a session tomorrow in any case. Inshallah, um, we will have now classes inshallah after Eid. I will announce that soon on the WhatsApp community. If any one of you haven't joined the WhatsApp community, in the description of the video you should be able to find the link in order to join that WhatsApp community. Once you join that, I'll make all the announcements over there. So thank you so much for joining us today. Take good care of yourself. Advance Eid Mubarak to all of you. Take Allah Hafiz.